In this question, we're dealing with the mechanics of factoring. They've given us something in the ax squared plus bx plus c format. And we see that there's something here and something here, but there's nothing in that first spot. So it's a reference here to the idea of BC factoring, which is what you do when you have numbers that are not the invisible number one in the B and C spots. And if you're doing BC factoring, you need two numbers that add to B, which is the negative A here, and multiply to C, which is 12. So let's think of numbers that multiply to 12. And those numbers would be 1 times 12, 2 times 6, 3 times 4. Now, the other thing to pay attention to here is we have positive 12. So our numbers are multiplying. They multiply to a positive. And what kinds of numbers multiply to a positive? Numbers that have the same sign, either positive and positive or negative and negative. Now, of those numbers that multiply to a positive, they're adding to minus a. So they're adding to a negative. So if our numbers are two numbers that are the same sign, but they add to a negative, they must both be negative. So thinking about how the numbers that multiply to 12 are 1 and 12, 2 and 6, 3 and 4, we just found out that those numbers have to both be negative. So we could have -1 and -12. We could have -2 and -6, or last but not least, -3 and -4. Now, if our numbers were -1 and -12, then it would factor to x minus 1, x minus 12. -2 and -6, our numbers would be x minus 2, x minus 6. And for the last one, x minus 3, x minus 4. So we just found 3 possible ways this could work out. And we can also think of foiling these out to find out what the original quadratic would have been. So for this one, first times first, outer times outer, inner times inner, and last times last. And we would have x squared minus 13x plus 12. For the next one down, first times first, outer times outer, inner times inner, and last times last. And we would have x squared minus 8x plus 12. And for the last one, let's make sure that doesn't look like a negative sign. And for the last one, first times first. First times first, x squared. Outer times outer, minus 4x. Inner times inner, minus 3x. Last times last, plus 12. Combine the -4 and the -3. X squared minus 7x plus 12. So now, what we found out is that there were 3 possible quadratics that could have fit the situation that they're talking to us about here. Now, a quick word. Why did they tell us a was greater than 0? That might have confused some people here. But that basically means that this minus sign actually really did make it negative. Because if the a itself were a negative, then a negative times a negative would have been a positive number. So that's just a quick side note there. But we found 3 quadratics that could have fit this. And so our 3 b's would have been 13, 8, and 7. Notice that I'm not saying negative, negative, negative because the minus was already there. So the answers are 13, 8, or 7.